Hi, I'm Stefano. I'm a software engineer at Aricto, and I'm the original creator of Kale. In this video, I'm going to show you how you can create AutoML experiments with Kale and Kubeflow. Kale not only allows you to convert Python code and Jupyter notebooks into Kubeflow pipelines and Katiba experiments, but it also provides the means to automate the discovery and training of machine learning models given some data source. And we call this AutoML. In general, the term AutoML refers to several machine learning techniques like hyperparameter tuning, neural architecture search, and meta-learning. In this specific instance, AutoML is a combination between hyperparameter tuning and meta-learning. More specifically, the meta-learning system suggests model architectures that it thinks will perform well on the input dataset. This suggestion system is based on previous knowledge on a wealth of other datasets and how closely the input data relates to them. So the meta-learning system makes several suggestions, and each suggestion is a configuration that is composed of a model architecture, an instance of the bootstrapping parameters of this model, and a data processing pipeline. Kale creates Kubeflow pipelines to orchestrate training and instantiating all of these configurations. So each configuration results in a Kubeflow pipeline that processes some data and then trains a model and evaluates this model against a certain metric. And afterwards, Kale takes the best performing configuration and optimizes further using hyperparameter tuning. All this mechanism is supported by ROC snapshots, so everything is reproducible at every step of the way. And Kale also takes care of logging trained models, processed datasets, and TensorBoard reports as MLMD artifacts, so you can use them and introspect them later. Let's see this in action. This is my mini-KF, Aricto's portable distribution of Kubeflow. And here I have a couple of notebooks. So in this notebook, my working environment, I have this bulldozer example that comes from one of our code labs. I won't go into the details of what this example is about, but if you want to learn more about it and have much more details about how the AutoML mechanism works, you can check the link in the description and head over to our code lab. So all you need to know right now is that we have a dataset that is composed of some features and a certain goal, a target value. So we want to build some models that can predict the resulting value from the input features. We don't want to spend time implementing our own models and iterating over them. Kale can take care of looking for potential candidate models, train them, and evaluate them on the input dataset. Let's see how it works. So all I need is to import some packages, to load my data into memory, and then potentially, this is not mandatory, but I can do some pre-processing here. And then package my input data, my features, and labels as a dataset, as a Kale dataset. Afterwards, I define a hyperparameter tuning policy, and you'll see later exactly what this is for. Finally, all I need is to call one single API, passing the dataset, what kind of task this is. In this case, it's a regression machine learning task, the metric I want my models to be optimized for, the number of AutoML suggestions, that is the number of candidate models and their configuration parameters I want to try, and that's it. I can just run this API, and this triggers Kale to orchestrate a whole experiment composed of several Kubeflow pipelines that together train several models and result in a hyperparameter tuning experiment that provides trained models logged to MLMD and backed by ROC snapshots. Let's go see. So since this experiment will take several minutes to run, let's see one that has already completed before. Here it is. So calling the run AutoML API creates a Kubeflow pipelines experiment. In this case, the AutoML orchestrate pipeline is the first one to run. And it actually, this is the pipeline that actually starts the AutoML mechanism by creating AutoML configurations. For each configuration, then in this step, Kale spins up a new Kubeflow pipeline. In these pipelines, you can see here there are 4 as we specified from the notebook. Each one of these runs 3 steps, one for data preprocessing, one for model training, and one for predicting. Each one of these pipelines is using a different configuration, so it will use a different model or same models but with different initialization parameters. Their output is the metric that we specified from the notebook. So all of these pipelines are training different models on the same dataset, but of course performing in different ways. Kale collects these results and picks the best metric value, getting the best configuration, and then tries to optimize this configuration even further by creating a new hyperspace around the best performing configuration. So Kale creates a KTIB experiment so that it can optimize the initial configuration parameters of the AutoML configuration. We can even see this experiment from the KTIB UI. If I go to the MLMD here tab, I have a handy link to navigate to the KTIB UI, which will show the KTIB experiment. And this is the policy, the KTIB policy that we specified in the notebook. Let's go back and see it. This one is the policy that defines how this hyperparameter tuning experiment will work. In this case, we set to trial count, and this is why we see just 2 trials. In a production environment, you would, of course, start this with much higher numbers. You could try it out with hundreds of configurations and then hundreds of KTIB trials. So once this is done, you're left with a bunch of pipelines. What can you do with them? So, as mentioned before, Kale takes ROC snapshots at every step of the way. So for each step of each pipeline, you have a reproducible ROC snapshot with which you can recreate the original environment and notebook, restoring them. Also, for each configuration pipeline that trains a model and predicts by testing on the test dataset, Kale logs MLMD artifacts, persisting the Kale dataset in use, the transformer that processes this data. It logs a trained Kale model backed by a ROC snapshot. This is a ROC URI that identifies precisely a ROC snapshot and the location of this model in the snapshot. And then Kale also logs a TensorBoard logs artifact that contains all of the data needed to create a new TensorBoard instance to inspect metrics and useful data about the model and the training procedure. We will see in future videos how you can exploit these artifacts to serve a model with KF serving, or create a new TensorBoard server with a single API from your notebook. So that's the very brief and high-level overview of how the Kale AutoML feature works. I hope you enjoyed it. I encourage you to go and take a look at the code lab. Again, find the link in the description, and see you soon.